now we start one of my personal favorite topics. I love circular geometry because it it draws together so many aspects of geometry and puts them in a place so that things make sense. And I get this feeling of peace when the world makes sense and when when things are logical and they're not all a state of entropy or chaos. So let's start with a circle. Today we consider the geometry of a circle. We already learned all about circumference and area, but let's remind ourselves of each of those formulas with each the formula for each with the mnemonic device. Cherry pie is delicious, apple pies are too. There we go. Okay, so this one will have a diameter of 10. Find the circumference and the area. Go ahead. Okay, so cherry pie is delicious. The diameter, that's what D stands for. Diameter goes all the way across, that is 10. So it's 10 times pi, which is... Now, they can ask the question in two ways. Sometimes they'll say, to give the answer in terms of pi. If that's the case, you're done. Okay, 10 pi is the solution. But sometimes they'll instead say, give the answer rounded to the nearest hundredth or the nearest thousandth, nearest tenth, nearest hundredth, anything like that. Then it would be 10 times. Instead of pi, we use 3.14. Sometimes they'll ask us to use 3.1416. You, of course, know that pi is not exactly 3.14. Pi is actually an irrational number whose decimal goes on forever and ever and never repeats. When we say 3.14, we're saying, well, it's just about equal to 3.14. For our intents and purposes, close enough. Or as my grandmother used to say, my great-grandmother, close enough for government work. 10 times 3.14 is 31.4. Now let's try that area. Okay, so area is pi times the radius squared, and this is the first moment that we have to have a little bit of caution. 10 is the diameter, but the formula asks for the radius, and the radius is always from the center to the edge. That's half of the diameter. So the radius is 5. So that's pi times 5 squared. And again, if they asked for the answer in terms of pi, remember 5 squared is not 10. 5 squared is 5 times 5, not 5 times 2. So it's 25 pi. And then if they want to convert it to a decimal, again, I plug in a 3.14 and I get 78.5 as my value. Okay, so let's try that again. Remember, cherry pie is delicious. Apple pies are too. And this time, I give you a diameter of 14. Okay. Do both, the circumference and the area. Okay, so if the diameter is 14, cherry pie is delicious. Circumference is pi times the diameter. If I want the answer in terms of pi, I am done. It's 14 pi. If they want the answer to the nearest decimal, I substitute in a 3.14 or 3.1416, however they give, whatever instructions they give you in the problem. That works out to 43.96. So the area is pi times 7 squared. 7 being the radius because it's only half the diameter. So if they want the answer in terms of pi, it's 49 pi. And if not, we multiply pi by 3.14 and I get 153.86. Okay. All right. So that's a little bit of basic background stuff that at times will become important with circular geometry. Now, some terms so that you understand some circle vocabulary here. E is the center of the circle. And then we are drawing two radii, EM and ET. A radius goes from the center to the edge of the circle. See, from the center E to the edge of the circle M, and also T. Next up is a central angle. Angle MET is what we call the central angle because the angle is at the center of the circle. MT is what we call an arc. An arc is a piece of the perimeter or circumference of the circle. All right, it's on the edge. Now, let's be perfectly clear. See what I wrote there, arc MT? That is not the proper symbol for arc. But I went into equation editor in this program, and they don't have a proper symbol for arc. This is the closest thing they have to it. You know how with a line segment, you draw a little line on top, a little segment on top of like MT? Well, this is an arc. It's a curved thing. So usually you do like an arch, like the left-hand half of a parenthesis, but you put it up in the air. They don't have that as a thing I can include. So I used this symbol, but remember, it should just be an arch like this. It would be like the left-hand bracket of a parenthesis, but turned so it faces down. All right. Now, chords go from edge to edge on the circle. So the beginning and ending points are line segments that begin and end on the edge of the circle. So in this case, we have a chord ME and a chord ET. And we would say that angle MET is what we call an inscribed angle. That's what happens when the edge of the angle is on the circle and it's made up of two chords. You can see arc MT right here. And again, that symbol is not proper. It should just be a parenthesis half up top of it. Okay, now one of the things about the relationship between the measures of these inscribed angles and the measures of a circle can be figured out by what we call inscribing and a triangle inside of a circle. So how many degrees do you get in a circle? I mean going all the way around the circle. Well, it's 360 degrees. How many degrees in the three angles of a triangle? Well, that's 180 degrees. Okay? So what does that tell you? Well, what it means is that everything that's in the triangle is going to be half of the circle, right? The circle's 360, the triangle's 180. So from here, we establish this principle that the measure of an angle on the circle, like an inscribed angle, is half the measure of the intercepted arc. Sorry for not closing the parenthesis on that. If the angle is on the circle, the measure of the angle equals 1/2 the measure of the arc. Now, I want to be perfectly clear and say that there is one exception to this when a secant meets a chord, but we'll deal with that if and when we come to it. For now, we won't worry about that eyeball exception. So here, you have a tangent meeting a chord, and the vertex of the angle is point B, and you'll notice that that angle is on the circle. So I immediately say to myself, the angle's on the circle, and it is not made up of a secant and a chord. It's a tangent and a chord. What's a tangent, by the way? A tangent is a line or a line segment that touches the circle in exactly one place on the circumference. So the chord goes all the way across, begins and ends on the circle. The tangent is a line that goes right to the edge of the circle, touches once, and then doesn't touch again. So what's the measure of this angle? Well, we said the angle's on the circle, so the measure of the angle is half the measure of the arc. The arc it intercepts is 148 degrees. Okay, there's the 148. Cut it in half, 74. Decide if each angle is an inscribed angle. If it is, name the angle and its intercepted arc. Just do the first one. Don't do all four yet. Okay, so for the first one, it's definitely inscribed because the edge of the circle, the vertex of the circle is on the circumference, and it's made up of two chords. Angle F is the inscribed angle, and arc GE is the intercepted arc. Let's look at number 2 now. Go ahead. Okay, now number 2 is also an inscribed angle because vertex U is on the circle. VU and TU are chords. Angle U is the name of the angle, and arc VT is the intercepted arc. Try both 3 and 4. Okay, so Angle 3 is not or example 3 is not an inscribed angle because the vertex is not on the circumference of the circle or the edge of the circle. Number 4 is definitely an inscribed angle because angle E, which is what it is on the edge of the circle made up of two chords, EF and ED. Arc FD is the intercepted arc. So remember, if you're on the circle, you're half the measure of the intercepted arc. Go ahead. Okay, so the angle is on the circle. It's not made up of a secant and a chord. So that means that the angle is half the arc. Half of 50 is 25. Now this cuts both ways. Not only does it say that the 25-degree angle is half the 50-degree arc. If I wanted to, I could also look at it as the 50-degree arc is double the 25-degree angle. Keep that in mind when you try this one. Okay, so if the angle is 35, well, the angle's half the arc. So the arc must be double the angle. The arc, it's not made up of a secant and a chord. It's two chords uninscribed. That's good. The measure of the angle is half the measure of the arc. So 35 is half of the arc, which I called x. So that means that x is going to be 70. Try this one. Okay, so like before, angle C is on the circle. It's an inscribed angle. It's not made up of a secant and a chord. So therefore, the angle is half the arc. Half of 80 is 40. Now, this is an interesting question. Find the measure of angle ADB and angle ACB. Go ahead. Okay, so a while ago we did some proofs, we did a decent amount of proofs, and we could do a whole lot of proofs with circular geometry too, but we're not going to. So if we were doing proofs with circular geometry, we would really hit hard a lot of things called theorems, and one of the theorems is that two inscribed angles that intercept the same arc are congruent. And you'll notice that angle ADB and angle ACB both intercept the same arc of 124 degrees. What exactly do I mean by intercept? Well, sometimes if I ignore AC and CB right now, it just looks like a pair of scissors. And if you were to cut with the scissors, you would cut from A to B. What you would cut with scissors is what we call the intercepted arc. So in this case, both of these angles are on the circle. If they're on the circle and made up of chords, which they are, the intercepted angle is half the arc. So angle ADB is 62, and also angle ACB. If they both intercept the arc and they both have the same formula, which they do, then they're going to have the same value every single time. Okay? Oh, let's take a look at the last one because I left the answer up. I didn't put the animations in. I always do something. So what's the measure of the arc? Well, the arc is double the angle. The angle is half the arc is double the angle. So if the angle is 57.5, then the arc is 115. Let's go back and try both numbers 5 and 6. Go ahead. Okay, so for number 5, it says arc CE is 180. So the angle is half the arc. Half of 180 is 90. For number 6, it wants the angle when it tells you the arc is 120. Well, the angle is half the arc, so it's half of 120 or 60. Next up, try these two. Get a little fancy here, plugging in a 20x. Try the first one, I'll give you the answers. Then you can try the second one. It's very important that you just write out the steps into an equation, and that will help you solve for x. Okay, so if angle HKM is 90 degrees, and then they start giving me some strange information here. They start telling me that arc HK is 80 and arc KM is 20x. How are you supposed to find x? But wait a minute now. If angle HKM is 90, then arc MH has to be 180. Now remember, the proper symbol should be used. So then the 80 plus the 180 plus the 20x make up the whole circle. So they have to add up to 360. Same side, same operation. Combine the like terms with the 80 and the 180. So that's 260 plus 20x is 360. Subtracting the 260, 20x is 100, x is 5. Let's try number 9. Okay, because angle UVX is 52.5, that means that the arc across from it has to be double that, which would work out to be 105 degrees. But that's also equal to, according to arc UX, by the way, there's the proper arc symbol that I don't have as an option on mine, which I can't believe. So 5x is going to be 105, dividing by 5, x is 21. All right, so that's our second video for the day. Those are all of the things that we're going to teach you about, at least for now, about angles on the circle. The measure of the angle is half the measure of the intercepted arc.